Thank you for taking time out of your busy agenda to be here tonight for the inauguration of Stephen Richardson to be President of the Institution of Chemical Engineers. But before we get the ball rolling, of course, we have to have our moment of safety. And let me just say that there are no practice alarms planned for this evening. If the alarm does go out, I understand it's incredibly loud, so you won't miss it. And that what we will do is we will exit by the door over there or over there. I think that's how they do it on the airlines, and I think there might be, no, there's not one at the back, is there? But look at the nearest exit door and pick the one you're going to go to, and then proceed down the stairs because the lifts will not be in operation. And once you get down to the bottom of the stairs outside, there'll be somebody there who will direct you to the left towards the bridge, where you can take cover out of the rain and await further instructions. All clear? Good. Right. Now to the highlight of the evening. My name's Ken Rivers. I'm the IChemE president for the next 7 minutes. And I'd like to, as I said, thank you again for taking time out of your busy agendas to actually being here with us tonight. And as the outgoing president, I've got both the honour and the privilege of being the warm-up act for Stephen. Now, it doesn't feel like 5 minutes ago that I was standing here at this lectern having my chain of office put on. The time as president has simply flown by. And I guess like many of the other former presidents in the room this evening, I found it a real honour and privilege to serve, and incredibly rewarding. I mean, as so many volunteers within the IChemE find volunteering rewarding and doing their bit, so it's been great doing my bit as president over the last 18 months. Now, when I was standing at this lectern 18 months ago, I talked a lot about leadership, and it's been a huge honour to lead and work with an exceptional board of trustees. Their enthusiasm has been infectious, and it's helped to restate and reinvigorate IChemE, along with the efforts of so many other members of this great institution. As well as leadership, I talked about being judged not by words, but by deeds and by action. And looking back over the last 18 months, we've made some significant steps on our journey to be an institution that's led by members, that supports members, and that serves society. The way people have come together to build and align around that vision has been absolutely immensely satisfying, and to all of those who have been involved in so many ways, I'd just like to say a really big thank you. For me, it feels like we have a renewed sense of purpose within the institution, that we've laid down some firm foundations on which we can build a professional engineering institution that is fit for the future. Our governance review is complete. It's enabled members to be more fully involved and engaged in running this great institution. We've created a new, smaller board of trustees that's wholly elected. We've established a Congress, which is a member-elected advisory body that is the voice of membership. And that Congress has got off to an absolutely cracking start. They provided a valuable member perspective on a wide range of subjects, from grand strategy to the details of policy and procedures. It's been absolutely fantastic to work with them. And I would like to acknowledge particularly our inaugural Congress chair, Nigel Hurst, and all Congress members for their contribution in making that such a success. It feels like there is a real hunger, both within the trustees and within Congress, to work together to deliver an institution that we can all be proud of. We've set out our goals for 2024, which clearly establish our priorities and provide a framework for action and delivery. And I know Stephen's going to talk a lot more about that in his presidential address. So all I'll say is the big high-scoring batsman is about to come to the crease. But the openers who've had to handle the fast bowling and some of the bouncers have got the occasional run on the board. And in the standards and qual space, Programme SMART has made great strides in streamlining our processes, making them more welcome to folk joining IChemE and to become chartered. We've run a whole number of successful pilots, and they'll be rolled out in the course of next year. So that's exciting. In the learned society space, we've recently established an elected committee to oversee the wide-ranging efforts. We're unlocking and sharing knowledge and information across our membership. Members can now sign up to an unlimited number of special interest groups and share their knowledge and connect with knowledge right across the full spectrum. And in the near future, our members will be able to connect into IChemE resources wherever they are in the world via their laptop, computer, and mobile phones. We want our members to feel valued and supported in their professional development, but we also want them to be able to contribute to solving the grand challenges that the world is facing. And I think that is the mark of a vibrant and engaged professional community. Delivering on these ambitious plans, which Stephen will talk more about, is going to rely entirely on our members and their involvement and engagement. And I think one of the most important things that we've established in terms of how we will work into the future is two quite fundamental mental models about the way we will think within the institution of chemical engineers. The first is led by members, supporting members, serving society. And this is the lens that we as trustees have used to assess each and every step of our journey so far, and which I think will serve us well as we explore and take future steps into the journey to become an institution that we can all aspire to. The second one is advancing chemical engineering's contribution worldwide for the benefit of society. Now, I know that sounds a great thing, and it's changed in one marked way, which is quite fundamental. We don't talk about advancing chemical engineering worldwide for the benefit of society. We talk about advancing chemical engineering's contribution worldwide for the benefit of society. It's a natural fit based on how we operate in the workplace, whether in industry or academia. We work with others and other disciplines, and it's quite the norm. And I think there's the opportunity there for us to build transformational change in our work with other professional bodies, and for the tendency to compete to be replaced by an imperative to cooperate, collaborate, and coordinate our activities. The world is changing, and the traditional boundaries of engineering are merging and becoming more blurred. And yet the contribution of engineering and science to address the global grand challenges has never been more important. Finding pathways that will equip chemical engineers, indeed all engineers and scientists, for the future is going to be vital. As I now hand over to Stephen and welcome him as the institution's 79th IChemE president, I'd like to sign off with a few words in Maori that many of you have heard me use repeatedly over the last 18 months. They have helped to continually inspire me on my journey as both president and trustee. Kua tahiti ki ko heranga mai, ki kura e haro tanu, he tunu nu rawa o mahi, ki a kura e mahi nui tanu. We have come too far not to go further. We have done too much not to do more. Thank you. We now move to the formal handover of office, following which we'll have the fun part, which is Stephen's presidential address. So I'd like to invite my good friend and our new president, Stephen Richardson, to receive the chain of office.
Thank you very much, Ken. Thank you. Thank you very much indeed, Ken. Thank you.
Good, thank you.
And now some words. Thank you very much indeed, Ken. My first act as president is to award you a past president's award, and that's for the outstanding contribution that you have made to the institution, and we are all really grateful to you. So thank you very much indeed, and you get a medal. There we are. And now, as they say, for something completely different. Thank you very much indeed, Ken, for your very kind introduction there. I hope I'm going to live up to all the words that have been spoken there. I'm really honoured and delighted to have been elected to serve as the 79th President of the Institution of Chemical Engineers. And I'd like to do a few thanks right at the beginning while everybody's still awake, including the people I'm about to speak about, okay? So the first is the troika down here of Ken Rivers, John McGarr, and John Pritchard. Only 6 months ago, I was a member of IChemE, but I didn't know anything about how any of this worked. And thanks to them, I've learned a lot. And as John will point out to me, I've still got a hell of a lot to learn. But so thank you all three, greatly appreciated. And I'd also like to thank Bev Garrett, because she makes sure that everything works okay and I get in the right place at the right time. That's really good. Thank you, Bev. And also Tara Wilson, and who's over there somewhere, and Rachel Fraser from the comms team, who put me through my paces before I did tonight. And however bad you think it's going to be, just think how much worse it would have been had they not put me through those paces. Well, the title of my presidential address is up there. It's called Process Safety, the Big Picture and the Systems Approach. And that basically reflects what I've been doing for the last 30 odd years when I haven't been teaching or with the family and things like that. And I've done all sorts of work on looking at high pressure systems, getting rid of the pressure in an emergency, and also looking at some big process accidents. And I'm going to tell you a little bit about that shortly, but first of all, I'm going to bore you with that most fascinating of subjects, me. Okay, so this first photograph here shows my maternal grandfather and me, aged 2. And he was the works engineer at the Liberty's Silk Printing Works in Merton in South London. It's now called Abbey Mills, so if any of you know that area there, that's what it is, and you can still see his workshop there. And when I was quite young, he made me a wooden screwdriver. But being an engineer, it was a beautifully made wooden screwdriver, so he gave it to me. And shortly after that, I was left in my playpen, and I used it to unscrew the bolt in one corner of the playpen, and escape was the next bit of it, so that was good. Well, after that, I did a lot of Meccano. I've still got a lot of it there. I don't play with it nowadays. I gave it up a week or two ago. But after that, there wasn't a lot of engineering. I went to school, yes, and then when I was at Wimbledon College, which is my grammar school that I went to when we still had those things there, I thought I was going to study chemistry if I went on to go to university. And chemistry was the thing, and partly because I had a really inspirational chemistry teacher. But a family friend, once coming to supper with my parents, drew my attention to ChemEng. Of course, I'd never heard of it. I had no idea what it was at all. But I did a little bit of digging. I found that it was actually much more what I wanted to do, the more applied end of things, actually doing things out there than chemistry. And if I'm offending chemists in the audience, bad luck. I decided that ChemEng, not chemistry, was going to be for me. My school careers master, just after I'd taken A-levels, just as I was about to leave, said to me, Richardson, what are you going to do next? So I said, well, I was going to go and study chemical engineering. And he came out with the standard answer, what's that? He then said, well, where are you going to study chemical engineering? And I said, I hope to go to Imperial College. And he came out with the lines I remember to this day. He said, so you're not going to university then? Thank you. He was a very perceptive chap whom I've met in later life. And he remembers, and so do I. Anyway, my later life was then spent entirely in academia, almost all of it at Imperial, as you can see, other than a brief sojourn in East Anglia at Cambridge. I went to Imperial in '69. That photograph there was taken on my first day there. And for those of you who know Imperial College, you will know that it was taken by Mr. Leonard Mulder. Yes. I graduated in 1972, but jobs were quite hard to find. Not quite as hard as 1971, but they were pretty hard to find. I was actually offered jobs by 3 companies: the National Coal Board, the British Steel Corporation, and the National Carbonising Company. And they were 3 companies that formed something called the Coking Industry Education Trust, and they sponsored me through university. And they all, each individually, offered me a job, which was very nice. And then they said they'd go away and think about which of them they'd like me to go to. That was in May 1972. I am still waiting to be told the answer, but I did form a view. So instead I went on to do a PhD at Imperial, and then after that I went off to my sojourn in Cambridge as a research assistant in the engineering and then in the ChemEng departments. But in '78 I was lucky enough to be offered a lectureship back at Imperial College, and I took it before anybody could change their mind. And I stayed there until I retired 3 years ago. And the early years there were mainly spent doing the normal things of teaching, research, and everything like that. But in 2001, I succeeded one of my colleagues in the audience here as head of department. And inevitably, after that time, you spend more time doing management. And that was fun most of the time. After that, I went on to run the engineering faculty, like my predecessor in the audience here. And then finally, I did some of the jobs at the top of the college as what was called deputy rector. That means deputy vice-chancellor, I suppose, in other speak there. They were the jobs that nobody else wanted to do. So there were things like academic promotions. I found that one of the most fascinating jobs I've ever done. I've met people who've done some really exciting things, just astonishing things there. And so I really enjoy doing academic promotions. They were good stuff. I have to confess, I did also meet some other people. I then also had to look after space. Now, if you're an academic, and I can see several in the audience, the word space gives a sort of Pavlovian reaction because you try and take away an academic space and you're really messing with them. So I had to deal with all those space issues when they couldn't be dealt with at departmental or faculty level. When I say dealt with them, I mean basically I got out of the room alive and a solution of some sort had got there. And the final thing I had to do was disciplinaries. That's all the cases that the departments couldn't fix up, the faculties couldn't fix up, and to keep the vice-chancellor, the rector, out of court, I used to go to the employment tribunals. And I can't say that was ever very enjoyable, but we did win every single case when we went there. So that was good. While I was at Imperial, I started getting a bit involved in IChemE. It took me 10 years after starting at Imperial to actually become a member. And you may say, why so long? Well, laziness, inertia, the normal things there. But also, in those days, I felt, and I know one or two of my colleagues did, that there was a slight perception that IChemE wasn't altogether welcoming to academics. But I did apply. I was interviewed by Simon Waldron, who may well, at this moment, in this audience here, be wondering why he did it. But anyway, he let me in, and my membership has stood me in really good stead ever since. It's given me real credibility. When you're standing in front of students, actually being able to say you're kind of a real chemical engineer rather than somebody else really helps. And when I was teaching the safety course and that sort of thing, that was helpful. And also when I've done a lot of consultancy, being able to say I'm a member and then a fellow. I've also met, and there are lots and lots of you here tonight, lots of other chemical engineers through IChemE, and many of whom are really good friends, and I'm really delighted to be keeping up with all of you. That's good. The IChemE has also been very good to me. It's given me a raft of medals there, which is very nice there, for services to IChemE, contributions to its publications, and my work on safety. And it also put my name forward with one or two others, but forward for a CBE, and you can see the picture of me there, bowing my head in front of Her Majesty the Queen. That was at Windsor Castle in 2015. And I'm not always at a loss for words, but I have to say it was quite an overawing experience. I'm hugely grateful to IChemE and all of you for all the things you've done in that way there. So thank you. Now, most academics talk about their research, and you might get a bit of a mention of teaching. I'm going to do it the other way around for all sorts of good reasons. At least I think they're good. That's partly because I think teaching is as important to a university's reputation success as its research. They're different, but they are both really important. And if you're going to be a leading university, you have to do well on both. I have to say I've done a lot of teaching. That is a partial list. And I really enjoy doing it. I wanted, in some senses, to be able to teach most of the undergraduate course at some point over the years there. And that's been fun. There are two bits you can see in green. One of them is called Mastery, and that's something I introduced in 1995 when we were doing a course review. And basically, Mastery is the bits of ChemEng that everybody has got to be able to do. Every single graduate has got to be able to do these bits. So it's things like sizing a pipe, sizing a heat exchanger, sizing a compressor, doing basic mass and energy balances. The things that you would be embarrassed, I, as an academic, if one of my graduates went out without it, or as a graduate, they would be embarrassed if they went out not being able to do that. It's a pass-fail exam. You can't get to the next year of the course or graduate if you don't actually do this. And it's still going, and indeed on Friday of this week I'm going to Mastery 2 as they update things. They have all sorts of ideas about where it came from, and I reminded them that I wrote those documents. I should say I stole the idea of Mastery from a university in Canada. It's from its medical school. The medical school there was having some problems with some of its students, confusing different bits of the human body, with some quite unfortunate results as a result of that. I also taught a course on problem solving with members of the congregation here present tonight, and that's a picture of me in action. You can see I normally do use the hands a lot more. I'm trying religiously to hold the lectern so I don't hit the microphone. This is the last photograph of me tonight, so it's getting better from here on in. But I would like to claim a record at this point here, because 4 of us wrote a paper with a colleague, Julia Higgins here, Jeff Maitland here, John Perkins here, and me, and I believe it is the only paper written by 4 presidents of the IChemE ever. Thank you. Thank you for that applause. You won't need to use your hands for quite a while now, okay? My main topic of research for the last 30 plus years has been modelling depressurization. That's getting rid of the pressure inside some high pressure system. always hydrocarbon. I'm afraid I am an oil and gassy sort of person, but that's been where the interest has been and the money has been. My colleague Graham Saville and I developed a computer program which we call Blowdown, and that has now been used worldwide on over 300, it's nearer 400 installations now, onshore, offshore, pipelines, a lot. I'm really quite pleased about one thing, and I'm also extremely relieved, and that is every single installation that we have done this on has never had an accident or a near miss, because my worry has always been, you do this, and something comes home to roost after that. Anyway, when I say that, not yet anyway. Now, depressurization, getting rid of pressure matters, and most of you will know this already, and quite a lot of what I'm telling you tonight is teaching you how to suck eggs. There's more to come. When you drop pressure, things get colder. Okay, gas in particular, anything under pressure gets colder. And that can get really cold. You can get down to minus 100. And then most steels start becoming brittle. And then if you're doing this in an emergency and you're getting rid of the stuff fast, everything's shaking like mad, it's brittle and you can fracture the thing. We've done a lot of work on this, and the work was sponsored by Shell, and I made sure I got a photograph with a nice shell on the side of it there. Shell, this was 1985. They gave us really quite a significant amount of money. It was 150 grand in 1985, which was quite a reasonable bit of funding. But also, it was a big act of faith on their parts, because we were going to go around, after doing some experiments like this, actually on some of their platforms, and do some things for real, which could compromise the integrity of the situation. So Shell have been very good to us over a great number of years, and we'll always be very grateful to them. We quickly appreciated we were developing a computer model, but that's the easy bit. The hard bit is being sure the computer model represents reality, which is quite a good idea. So we quickly got into the importance of experimental validation. And a lot of what we've done small-scale stuff in the lab, but we've done an awful lot of our own, but also with clients all around the world at full scale. And that's for two reasons. One, the industry doesn't believe it if it's small scale. I mean, you've got to show me on a big one, okay, when the thing really shakes. That's quite important. So for credibility, but also there are quite a lot of effects that really don't scale very well. You can do them in the lab in leafy South Kensington opposite the Iraqi embassy, okay, but it's quite, you can't do something very big there or very dangerous. So doing those experiments at full scale was really important. And the reason is intuition, and I'm mainly a much better place. Now, this is my little bit there. There are a lot of myths in this sort of area here, and I'm going to give you one. Okay, just the apology now, that's the only equation tonight, okay? I am a nerd, aka a geek, okay? And I had to have one there, otherwise you wouldn't have known who was talking to you. This is looking at a discharge, at a restriction orifice, and normally you fit that downstream of a blowdown valve to get rid of pressure. And basically it has a little bit in the middle there, which is a restricted bore, because that's what controls the flow rate. The flow with the upstream pressure at 100, 200, whatever it is, bars, goes sonic there, and that controls the flow rate. And the mass flow rate through the little hole is related to the density rho, the speed v, the area a, by a correction factor called the discharge coefficient, and almost everybody knows that. And almost everybody knows, not quite everybody, almost everybody knows that for liquids like water, CV is about 0.6, 0.58, 0.59, 0.6. You look it up in Perry, and there you are. Quite a lot of people use 0.6, whatever it is, including gas flows and everything like that. And I'm giving you a little bit of this is wrong, okay? So it's not actually right. Because when you actually do the experiments, and we've done a lot in the lab, but we've done a lot. I'm talking about thousands, okay, on plant around the world. The actual value is about 0.9. All right, 50% more. That's all right. We published that work 13 years ago in PSEP, Process Safety and Environmental Protection. So one of my contributions to IChemE's Learn It Society. That's good. And despite that, and despite all the evidence, some people still use 0.6. And the argument, and forgive me for just going through this because there is a small point here. They say if it's actually 0.9 and but you've used 0.6, then the hole is going to be 50% bigger than you think it needs to be. So the flow out of the hole will be much faster. So whatever you're trying to blow down in an emergency, say, is going to be got rid of more quickly. And that's a good idea. If there's a fire, you really want to get rid of the stuff. So far, so good. The difficulty is, of course, that the flow rate downstream is also 50% higher. So the whole flare system and the vent system, which is not designed for this, okay, has got 50% more flow rate. And the trouble is, compressible, fast, high-speed fluid mechanics is very nonlinear. Okay, so it's not going 50% faster. It can go 2 or 3 times faster. It can go sonic. It chokes. Okay, then the whole thing vibrates like mad, and the things sometimes fall to bits. So your safety system you actually destroy by making it conservative upstream. And the point about that, which is trivial, but I'm going to make it anyway, is the system, when you're looking at safety on this, is not just what you're trying to blow down. It's the whole damn lot right up to the flare tip, kind of obviously. And so that's kind of getting into a little bit about systems thinking and, crucially, doing it for the right system. Okay, misidentify the system, solve the wrong problem. Anyway, once we developed blowdown, we got also into investigating a number of accidents, and there are people in the audience here with whom we've done those. I've just listed 5 there. We've done several others, but these are some of the big boys there. I'm only going to talk about Piper Alpha tonight. You know, if you had another 2 or 3 hours, I'd be quite happy to do any or all of the rest of them there, but we'll only do Piper. The obvious common feature of all those is, of course, that large numbers of people died on all of those there. And of course, that's part of the reason why this really matters. That tragic loss of human life is really quite important to us. And I do worry, and I know Trevor Kletz used to say this repeatedly, so everything I'm saying tonight is non-original. Lessons, we learn the lessons from this sort of thing here. They gradually get lost as succeeding generations go on. They simply get out of the system there. And that's, he called it, I think, corporate memory. Corporate memory is short and seems to be getting shorter, faster and faster and faster and faster. And I've talked at numerous places where I'm told that's a solved problem. Well, no, it isn't actually. It really isn't. A less common feature of all of these accidents and several others is actually, it wasn't just, when it was Piper, it's not just Piper, the platform, it's all the infrastructure, the pipelines and everything connected to it. And ditto for all of those other examples there. Getting the system right means you can start looking at the safety of that system. And if you ignore that, you're actually ignoring some of the problems that you're going to be wanting to solve later. And again, that's about teaching you how to suck eggs. I know this is all terribly obvious to you. The thing I find, though, as a consultant, I've done these 300 plus jobs, the number of times, and it might be, it's in tens, it's not in hundreds, but the number of times I'm asked to solve, to do something or other, and they say, that's not the issue. That really isn't the appropriate system to be looking at there. So I can spend a lot of time. I can earn a lot of money, and that's very nice. Okay, solving a problem that is just wrong. And I'm afraid I now, very quickly, within a year or so of starting this in the early 90s, we just wouldn't do that. If it's the wrong problem, we're not going to solve it. Okay? And I think that's important. Well, before discussing Piper, let me tell you about 2 little accidents, or near accidents I had. And I'm conscious that I'm going considerably slower than when I rehearse this. So as you fall asleep, well, we'll see what happens. When I was an undergraduate, I did vacation placements at the coking industry education trust. So I worked on 2 coking plants. Of course, neither of them is here anymore. There are no coking plants anywhere pretty well. The first one was at Nant Garw, which is up the Taff Valley from Cardiff. That's the top 2 photographs and the one on the left. And the second one was at Worsborough, which is just south of Barnsley. And I was the only person who spoke with a non-Yorkshire accent on that whole plant. And I got the butt of every joke there could possibly be. My first experience of an accident was at Nant Garw. And the way you make coke is you have a battery of ovens, and you do each in turn there. You lift the hopper at the top there, charge it up with coke, heat it for a bit there, drive off all the unpleasantnesses there. And then when it's finished, you push the coke out, and you can see a picture of coke being pushed out. So it has a pusher on one side of the ovens and a hopper to receive it on the other side of the ovens. And the trouble is, the person driving the pusher can't see the person driving the receiver because there's the big battery of ovens in the way there. And so I think most of you are already ahead of me on this one here. One day, the driver of the pusher, for some reason best known to himself, started using yesterday's timetable, whereas the driver of the receiver was still using today's. So, of course, the Coke came out of the wrong oven. And that was the time when 2 or 3 of us were walking along past the ovens. And all you're aware is this immense noise and then this enormously hot stuff radiating like mad, tumbling towards you. And we moved away. That's code for ran for our bloody lives, okay, as fast as we could. Luckily, no one was hurt, but that's what it was like in those days. My first experience of a near miss was at Worsborough, the one near Barnsley, where I was talking to the plant manager, and we looked out of the window, and there was the gas holder supplying gas off to Barnsley, and a man was up at the top there with his paintbrush painting it, with his cigarette in the other hand. So the plant manager issued Anglo-Saxon words to me, and went off to have words with the man, while I also moved quite fast, but in the other direction. Remember, this was all before Flixborough, 70, 71 this was there, before the Health and Safety at Work Act. And life was simpler then, unfortunately. Well, apart from getting married to Hilary, who is here tonight, and the birth of my children and the birth of our grandchildren, the Piper disaster is probably the most significant event in my life, even than becoming president of IChemE. But I realise I'm on dangerous ground there, okay? So I spent a lot of time, as did others, giving evidence at the ensuing public inquiry and indeed at an insurance case after that. What I'm about to say, though, about this and 1 or 2 other accidents is not about criticising anybody, and it's certainly not about blaming anybody. It's about what lessons can we learn, and do we really learn those, okay? I'm not in a position to criticise anybody, and I think everybody that I'm aware of did, in the circumstances, what was the best thing. Hindsight is a wonderful thing. This is Piper in October 1987, so this is 9 months before the disaster, and the platform is just a bog standard Gulf of Mexico design, put in 150 meters of water, and then 8,000 feet below that is the oil field. I'm not going to give you a long, but here just a few photos. The first explosion was at about 10 o'clock. You can see up at the top there, they have lots of twiddles. The photos are all in the right order, and they're about the right timing, but the exact timing, nobody actually knows because people weren't actually particularly looking at that at the time there. So this is about, assuming the first bang was at about 10 o'clock, which it was, then this is about 15 seconds after that. So this is not the first bang, this is the fireball after the first bang. And what you can see fairly clearly on it is there's a fireball there, and that is the same fireball. In other words, it's gone all the way around the back of the accommodation module, which is where all the men, 226 of them, and they were all men. There weren't a lot of women in the North Sea in those days, not in the UK sector. That's where most of them were off duty at the time. So that's 15 seconds after the first bang. And that's another 10 or so seconds later, certainly less than half a minute after the first bang. And you can see now the fireball is up on the top of the helideck. And at that time, on Piper, as on any of the platforms, to get off a platform, helicopter evacuation was accepted as being the way off. That's how you get off. Okay? And as in so many ways, and I'm not going to teach you, or sorry, tell you about any of those, or all the other ways. So many things that we had assumed, humanity had assumed about how we operate things, just got changed by Piper, you know, and you see that in lots of big accidents. They just change so many bits of spilling crude oil, and basically there's what's called the 83-foot level, which is somewhere up there, and there's a 68-foot level somewhere there. So it's about 15 feet high, so it's rather taller than this room here. But spilling oil from upstairs fell downstairs and created a pool fire, and you can see that there. And what that did was, running over the ceiling, or just underneath the ceiling of the 83-foot level above, is the main oil export line, a gas import line, and 2 gas export lines. And so that pool fire, within minutes, is starting to heat them up. Okay, the pipelines are uninsulated, they're painted, but there's no fire insulation or anything like that on them. And this shows the fire. on that pool fire there. And then a bit later, and I've said plus 1 second, plus some short time later, one of those gas lines. So within 20 minutes of the first bang, one of those gas lines, the line from Tartan, has ruptured. It's 18 inches diameter, 117 bars, and it ruptures. And that's basically, at the moment, fractionally after the rupture. That's about a second later, okay? That's 3 tons a second of gas. At the time, the UK used gas at about 2 tons a second. So that's 1.5 times the UK gas consumption going off there. And the amazing thing on that, and I still am amazed, is that Piper survived that sort of stuff for about an hour, which is, for a widely criticised design, it was actually good stuff that it could do that. However, eventually, the fires took hold. The main oil line, the other 2 gas lines ruptured. It was the MCPO1 line that went next, then Claymore, then the oil line. And by about midnight, and it's about midnight, most of Piper has disappeared. It's just held up. The wellhead end is still there, held up by the wells. The platform itself is more or less gone. And that's the fire there. And that's about 200 meters high, the flames, 650 feet. And the smallest estimate of the power consumption there is 100 gigawatts, and up to maybe 800 or 900 gigawatts. The difficulty is not many people have flames that big that they can do scaling from. Okay, so it's actually quite difficult to estimate that. The public inquiry was held at the Bridge of Don, which is just north of Aberdeen, just across the road from the company that operated Piper. And Lord Cullen sat there. Frank Lees, who was professor at Loughborough, sat this side. Brian Appleton, who was from ICI, sat there. And Malcolm Ford, who was chairman of Britoil, when we had Britoil, sat there. And then there's a witness who sat somewhere around here with a stenographer. And then round here are a huge number of benches for all the interested parties. And I can see that I'm getting, pleasingly for me, quite rapt attention tonight. Let me tell you, when you're giving evidence in court and you've got a load of barristers, they pay attention to every comma, slight hiccup, and everything you ever say. It is terrifying. The inquiry that Lord Cullen led and produced this report here. It's a 2-volume document, and I think it is simply a true masterpiece. It really does merit reading and rereading as a way of not losing the lessons from the past there. How Lord Cullen, who knew nothing about oil platforms before this, with 3 people who did, but could actually, and all the barristers, and great credit to the barristers as well, that they could actually get hold of a problem like that and really get to the nub of it and come up with some really stunning conclusions there. And of course, for a lot of the barristers, 3 weeks later, they'd forgotten it and they were doing it. It's that sort of mind. But Lord Cullen, I think, I'm not sure there are many other people who could simply ever have done that. What I do worry, this is the report here, and I think it is well worth looking at. Quite a few of its lessons do seem occasionally not to have been learnt. And again, I've given talks on Piper where people say, well, we know that, but they're not actually changing anything there. So until they change anything, it's like Ken said earlier, words are one thing, actions are a little bit more impressive, aren't they? But I am delighted that IChemE has not forgotten. Last year was the 30th anniversary of Piper, and IChemE published several papers in the Loss Prevention Bulletin, articles in the Chemical Engineer, blogs, and a press release. And the thing I'm especially delighted about is that the Safety Centre, IChemE's Safety Centre, and its Safety and Loss Prevention Special Interest Group led to the availability of the report now. It's a free download on the web, you can get it. And that's, I take my hat off to them, that's a real act there, that's really, really good. Now, there are hundreds of lessons from Piper. The Cullen report made 106 recommendations, the government accepted them, industry did them. That's great, it really is. And there are lots of other lessons as well that have come out from it. I'm not going to discuss those. Again, I could bore you, and I regularly bore students and other lesser class of people. One of the key things, I think, one of the benefits of Piper is that actually, in the end, we don't actually know what happened. We can form a pretty good guess, and the evidence points quite strongly one way, but there are others, there are some near misses, also rans, etc., etc. And so that meant that the Cullen inquiry had to come up with lessons that it might not have caused it on the 6th of July, but on another day it could quite easily have caused it. So we had to pick up all sorts of lessons, whether or not they caused the disaster itself. And there are two that I'm going to pick up because they're just coming back to this idea of systems thinking. I know it's a hobby horse, bad luck. The first one concerns where did the oil come from that led to that pool fire that heated up the tartan line, because once you'd lost the tartan line, effectively you'd lost Piper. It was just going to go, trying to stop it at that point would have been very difficult indeed. So that's the tartan line, that's the one that ruptured, somewhere there just around about Piper. The question is, where did the crude oil come from that actually led to the pool fire that heated it up? And put crudely, put simply should I say, there wasn't enough crude oil on Piper for the fires that were there. So where else could it come from? Well, there's only one other place it can come from, and that's the main oil line there. So either the main oil line shutdown valve didn't shut, and remember this is a 30-inch oil line, so it's got a ball valve, 10 tons, 15 tons, a big beast that's got to shut really quite hard to stop that. Or you get a rupture of some sort, not a huge one, but nevertheless a rupture of some sort there close to that ball valve on Piper, which enables oil then to come back onto the 83-foot level and dribble down to the 68-foot level. So that was the oil coming back. Now, the curious thing and the difficult thing is that Tartan and Claymore, two other platforms attached, as you can see here, by gas and oil lines round Piper, were still exporting oil for quite a long time after the first bang on Piper. And the reason for that actually is quite good, and we'll do it in just a second. But undoubtedly what that meant is they were still Tartan over to Claymore, Claymore up to this. It's not a T, in fact, it's a Y there. And then instead of the 120 miles back to Flutter that way, you've got 8 miles or so, 8 or 9 miles back to Piper there. Small hole or small not shut valve there, you're pumping oil back on to Piper. Now, this is not to say that because Tartan and Claymore kept producing oil, that's what led to the overflow. That gave enough oil there. Okay, you can't do that calculation. It's just too subtle. We haven't got enough evidence for that there. But the point I'm making is whether or not that contributed to Piper on the night. Okay, the fact that they were still connected to Piper meant that Piper is not isolated by its shutdown valves. It's Piper plus the lines plus what the other platforms are doing. And if you don't look at that, you're not actually solving the real problem. So that's why I say no platform is an island, and Piper certainly was not an island. The second thing that comes on this, and it's the same picture here, is that when Piper had its first bang, okay, comms went pretty quickly. Piper was there first, Claymore came second a year later, Tartan came third a year later than that. So Claymore and Tartan ran all their comms through Piper. So when Piper went down, the other two platforms were basically left in the dark, and that partially explains why they kept producing, of course, because they didn't actually know what was going on. It's more complicated than that. But the point about it is that when you look at the system, it's not just the IChemE's hydrocarbon system, it's also the comm system, it's all the other bits and pieces. You've got to look at that big system in all its aspects if you're really going to say something useful, in my view. And from all of that, I draw one big and totally unoriginal lesson. Okay, you'll be shocked how unoriginal this is here, which is if you don't look at the big picture over the whole life cycle of whatever you're looking at there, I think you're wasting your time. Okay, you're certainly not considering safety. If you don't look at the big thing, you'll certainly miss bits, and they may be crucial to whatever event's going to come next. And so my corollary is safety is nothing without a systems approach, or if you haven't got a systems approach, you really are not discussing safety, in my view. That then kind of leads me to think a little bit about how we teach systems at university. So I'm going to get back a little bit back to teaching there. And Bill Wakeham, who couldn't be here tonight, spoke about this to the Computer-Aided Process Engineering Special Interest Group. I had to read that because to get all the words right. That was in 2014. He also spoke about it briefly in his presidential address years before that. And like him, I am absolutely convinced that if you're going to do systems teaching, and I think it is the core of what IChemE's is about, you have to integrate it with that core. It's not an add-on, it's not separate bits there. It's just the natural lifeblood of what you're doing as part of an undergraduate course. As soon as you make it separate in any sense there, the students, it suddenly becomes a second-class citizen in some sense there. It's got to be absolutely tied in. And the other thing is actually to teach it explicitly. I've often talked to undergraduates who, I never knew I spoke in prose till you told me. And they never knew that they that were doing systems thinking until somebody actually told them that's what it's about there. But actually, once you start thinking that's what you're doing, okay, you really do get, you can go so much further with the whole subject. Okay, well, that's enough about all those sorts of things there on safety. Too much, possibly, you may say. That's big picture for safety. I'm now going to talk a little bit about big picture for IChemE. It's what Ken promised you, okay? You know what the word disappointment is, don't you, Ken? Right. So what I want to look at now is what's called Strategy 2024, which is the 5-year look ahead that IChemE has recently published. And I regard that as this is IChemE's big picture. This is where we're looking. We're going to be advancing it, but it is the big picture for the next 5 years. And if we do it, I know IChemE is going to be more successful in what it does, and the converse is also true. And how will we know it's been more successful? And I've abbreviated the document considerably here, so please forgive me when you know all the other words there. But IChemE will have been successful if we're even more that's the wrong button. Even more respected for the professionalism and technical competence. That's us as members, that actually we know what we're talking about and we're keeping up to date and we're doing all that stuff there. Okay? That's kind of important. I think it's what everybody in this room would want to be doing. It's also more recognized, better recognized as a vibrant learning society. Life moves on. We're going to be doing new things. Okay? Getting that back to members is really quite important to us. Third one here is engaged membership, receiving and adding value. And the key word to my mind there is engaged, that actually we're actually doing this together because we want to, and the more of us can do that, the better. And then the final bit is what's known as the high-performing organization. And that, without naming names, John, is your bit. Okay, that's basically how the inside of IChemE works there. So that they've got a database, they know who you are, they send you your subscription reminder, all those sorts of things there. They make the machine work better, even better than it does now. All of those things are discussed in the Strategy 2024 document. If you haven't got it, I recommend that you do so. You could certainly download it, and we may even have some paper copies for those of, who need that. Or maybe not. I'm not getting an immediate reaction. We do. Excellent. Thank you. Thank you. Oh, good. Having got that strategy, of course, the job now is it's up to all of us, led by the Board of Trustees, but with all of us working together to deliver the strategy. And of course, that raises the obvious so what question. Okay, I was known at Imperial College for, as Mr. So What by Hans Mikkels. You'll remember that there, because after the seminars, students would tell us things, and I'd say, yeah, but so what? Where does that get us? Well, the so what bit here is, if we do achieve this strategy, and I'm sure we're going to do it, then, as Ken has already mentioned there, we are really going to be truly led by our members. We're a membership organisation. That's what the game is here, guys. And we are going to be led by our members and supporting our members. So that's putting in and getting out. It's all that bit there. But also, and crucially, serving society. That's what being a chartered engineer is about. It's where we get our charitable status. But being a chartered engineer, that is the game. Okay? We are a member society. That's fine. But we are doing that extra bit there, serving society. Now, in a recent article, this is where I get to name quite a few names, so get ready, Ken. Not that I'm going to call it, yes. In a recent article last year, Ken wrote about developing the strategy, and he said it was hard, but then he pointed out that the harder bit was delivering it. Spot on. I would just add that this strategy is a 5-year strategy, so it's not all going to happen tomorrow. Okay, we will do everything as fast as we can, but it is a 5-year strategy. It certainly can't all be done by me, however much you'd like me to do it, nor while I'm president. I'm only here for 18 months. I'll be past president with any luck after that. But what I do say now to all of you is I am going to do my utmost to get as much of it done as we can and to leave all the rest in progress so it actually does get done. And I want to pay particular attention to 4 Okay, so going into name names. Judith, as we know, Judith Hackett, after Grenfell, wrote about safety being a mandatory element in every engineering degree. And I absolutely buy that. I am often surprised. I've talked about safety things in civil engineering departments, all sorts of other engineering departments, and they do safety. It's normally 6 hours. Okay, I'm exaggerating, and some do it really well, but some really, in my view, do it at a pretty low level there. I think the idea of process, where process is whatever is appropriate to you, if you're building bridges or building blocks of flats or whatever, it's not quite ChemEng, but it is the big picture for them. Understanding safety there is really key. And I think IChemE is in a really good position to assist with that. It's not to tell us to assist. We want to be doing this together, and I think that's really quite important. And the final thing on this little bit here is improving learning lessons from past mistakes. And again, Ken, I think this is your final go-through on this thing here where I quote you, talked about learning lessons leading to good practice, leading to common practice. And that absolutely is it. That's when you don't have to keep reminding people because it's just what you do normally. The trouble is we often get stuck at a bit earlier than that. And that's the issue we need to face there. My next little theme is looking at our excellent chemical engineering departments. There are several new ones, several small ones, and they've got issues of their own. Being of a certain size does help you being able to do teaching and research together. And if you're not big enough, that is quite hard. Now, there's a tremendous pressure on academics to do research, and that's often led by things to do with promotion, perceived promotion criteria, and that sort of thing. And let me say, before I give you the bombshell, I really value that huge diversity of research that chemical engineers do. They do it in biomedical things there, they're growing bits of skin and all that sort of stuff there. I didn't even know what it was, and there are things I hadn't even dreamt of. It's really important that we can do that sort of thing. But at the risk, and you know who you are, at the risk of alienating all, or some, most of my academic colleagues, I do worry there's a little bit of a hole at the centre, by which I mean, who's going to teach some of the basic aspects? You know, if you look at some departments, they've got experts in all sorts of peripheral bits of ChemEng, but there are the central bits, and that's the sort of things that I would count as mastery or process safety. I know some departments actually have difficulties doing this, actually having the staff to be able to do this. The photograph there shows a creosote bush. Yeah, it's a creosote bush. Okay, it's in a desert in America, and it's about 11,000 years old. Okay, because a creosote bush starts as a little plant, okay, and it grows, and it spreads, and it dies off in the center. And that is my kind of notion of what I don't want a chemical engineering department to look like, which is it's all around the edge and nothing in the center. To conclude this point, John McGarr, yes, John, it's your turn, okay, spoke in his presidential address 2.5 years ago, 2017, about the impact of big data, artificial intelligence, digitalization on ChemEng. The result of that, and it's coming, and it's going to make a massive change, is that we're going to have to rethink aspects of undergraduate course design, delivery, accreditation, and also things like CPD, or we're going to get left behind or ignored by others. So this is really important. I'm particularly delighted that John has been pushing us on this and that IChemE is already on the case. And indeed, only last night we met with reps from several other professional engineering institutions. And I think they're starting to get into a good place where we can do something significant together, because that will help. Third of my themes, there are only 4. I want us to be able to celebrate the centenary of IChemE in 3 years' time. The brown photograph shows George Davis, who was the founder in 1922. ChemEng has made hugely valuable contributions to society, humanity, a lot in the last 100 years. And I want us, A, to celebrate that, but also to look forward to actually how we're going to do the next 100 years. That's really important, I think. Amongst other things, and now it's Jeff Maitland's turn, Jeff talked in his presidential address in 2014 about climate change. And if we're actually going to be relevant for the next 100 years, I think IChemE has to speak up, say more, do more on climate change. And I know that the IChemE's Energy Centre is already doing and has done some tremendous work in this area, and we should be really proud of that. That's great. But I think we have to do a bit more. It's quite difficult if you look at the website for IChemE at the moment to see everything, a statement about this, and I think we need to be able to say more about it. And if we don't, we're going to get stuck with some really strange policies that have little or no evidential basis. And if you don't believe me, just imagine, if you will, the Oval Office. My final theme is number 30, 2 more to go, to ensure that all parts of IChemE work better together. I really do want to urge and encourage more members to become more involved in IChemE. And then in some ways, this has nothing to do with IChemE or being a chemical engineer. This is about a group of people wanting to work together. Because if we do want to do that, and we do that, all the other strategic aims are much, much easier. And what's more, if we don't, they're just bloody difficult to do. They are so much harder to do. One way I'd like to do that is to recognise and reward the huge number of volunteers that we get. We do all sorts of prizes for research, innovation, technological innovation, and that's great, and we should continue that. But we have a large number of people who make IChemE tick, out in the member groups, out in the special interest groups, and so on and so on. They simply make it tick, and I would like to recognise them more and say a big thank you to them for everything they've done. The final thing I'd like to do is this thing, it's called about building trust. I'm not going to go into any of the events of the last couple of years, partly for ignorance on my part there, but there is a job to be done there. Trust is something that doesn't just happen. It's something that happens by people working at it continuously or continually. I'd like to say, as president, I'm always happy to talk to members about anything related to IChemE. And actually, I think, John, you say a similar thing here. I really, it's the way I read Imperial when I'm doing bits and pieces there, I really prefer to hear about things when they're niggles before they become issues. Because so many of them you can head off at the pass, and 1 or 2 of them are really hard, and so yeah, they become a real issue. But so many niggles can be deniggled. If you would like to do so, I'm happy to meet any of you individually, together, wherever, however. But at the end of the address, in 2 slides' time, there'll be my email address. So if you can't think of any other way of getting hold of me, send it to my email address, and I will talk to you about anything. Right, penultimate slide. No apologies, that's the buoy marking the site of Piper wreckage. Piper's wreckage is down there with the legs chopped off and all the various other bits and pieces. And Piper Bravo is in the background, 800 meters away. And I don't apologise for putting it there, because I think its many lessons are as relevant now as they were 30 years ago. We forget them at our peril. Now, I know that sounds a bit downbeat, and I'm really not downbeat. I think ChemEng has a really great future. Chemical engineers will make great contributions to society. And the good thing from my point of view is that our tasks are going to change, and they will always be challenging. But my idea of hell is a boring Sunday afternoon. Okay, I'd much rather be challenged than bored with the same old rubbish. Okay, let's be challenged, let's do it. And I'd say the challenges are why I've enjoyed almost every day of my life. 1 or 2 of the challenges I've had, and some of us have had there, you could do without, but most of them I've enjoyed. Jonathan Seville, the last person in my name-dropping sequence here, in his presidential address in 2016 asked, can IChemE remain relevant? And my emphatic answer is absolutely yes. We must, and we will. And so with that, can I thank you all very much for your attention. That's the email address. I'm done. Thank you.
So how do you follow that? Ken gave an analogy. He said he was the opening batsman, and I live in Australia, so Steve Smith's been knocking them out of the park, and I'm the sad night watchman standing between you and drinks. So have pity. I'll try and do a very quick summary of this stuff. Look, thanks, Stephen. That was, on behalf of all of the membership, you shared a lot of passion there, and you shared your background, and I think we all recognise in this room and the people that we're broadcasting to. you made an emphatic central case. And that's it. I won't repeat your words. Your central case was safety, a specific area of safety, which is the blowdown, and also going through and looking at the hazards and the learnings that we can bring out of what has happened in the past. And all too often we have these major events in our industries that, yeah, we do learn from, but we have too many of them. And obviously you enjoy teaching. I wish I'd have been taught by you. That would have been a lot of fun. My attention was piqued a little bit when you said, and it's a theme that I find interesting, jobs were hard to find when you graduated. I was at a different spectrum. I was at a time when jobs were really easy. That's why I got a job. We live in a cyclical industry, and we've seen that as we go up and down, as the big commodities move, it becomes harder and then it becomes easier. And that's a cyclical world that we live in. As we move to IChemE 100, we're going to look at the future in a number of areas. And I just wonder if we've got an opportunity to break that cycle as chemical engineers go everywhere. I'm seeing them in the renewable industries. I'm seeing them in the industry that I know very well, which is minerals. That's an interesting little piece of logic to play with. Also, just like you, a lot of the industries that I started with are just not there anymore. And that's the way it's going to be. And it's probably going to get faster and quicker, and we have to adapt, and we're living in a world that's adapting quite a lot. I find it really hard when you say ChemEng wasn't for academics. And how long did you escape? Was it about 10 years before you? We were at a different place. Academics teach, they educate, and they provide the chemical engineers that keep our great profession going. And also academics do that research that pushes us forward. So we're not, it's not academics versus industry, it's we are joined, we're integrated. And thanks for pointing that out. Mastery, yeah, I get it. That concept of mastery, I deal in a number of other industries, and this digital stuff that's floating around us, if we're not careful, it's going to undermine that mastery. That's at the core of what we need to do, but thank you for reminding us that. Personal safety incidents in your career. I reckon we could all hold a major symposium just on that matter. You know, and what was acceptable in the past that now is absolutely not acceptable. But that's okay. So what is acceptable today that in 5 and 10 years' time is not going to be acceptable? How do we get there? And thanks for covering Piper Alpha. It's a really, really small world. Before I went to university, was a labourer on the building of Flotter. I did that for two summer periods, and it was a really interesting and very happy time. So the Cullen report is important, and I'm going to just speed up a little bit and go into that. I've read it in detail. I'd like to give you one observation. When you say that we forget and that some people are telling you that institutional knowledge has been fixed, I disagree violently. I actually, because I was who I was in a very large corporation, I have a data set of 1. We looked at how fast institutional knowledge faded. We actually had the business analysis people go out there because I got fed up of going through the same stuff. Our data set of 1 is about 9 months. So if you do a major change, and that's it, and I'll use entropy here, you put significant energy into that system, and then you just leave it to institutional knowledge to carry the thing forward, we reckon it was about a half-life of 9 months. And you could go through, it's what consultants make a lot of money doing that. So are we, if you accept that, this is me going a bit kind of weird, if you accept that entropy view, are we part of the re-energizing of these systems? Are we the people that can maintain that institutional knowledge, keep pumping new energy into the systems so we don't forget Piper Alpha? We don't forget Flixborough. I did a caprolactam plant. So thank you for doing that. The strategy 2024, fantastic. It's been marvellous to be involved in that, but it is only a 5-year strategy because the world will change around us. Industries will come, industries will go. What we're trying to achieve there, clearly we have to do that, but we've got to be looking for what the world's going to be doing to us in the future. And you've got clearly a basic drive that you've given to your academic colleagues, and I'm sure they've taken notes, and I think there's probably been a bit of twisting. So mastery and who will teach process safety, well, you've now got the chain. Go for it. Push hard. Look, I'll close out now. one of our past presidents was 100 this year, and I wrote the gentleman a letter, and I said I'll have to quote it from here. I say, all IChemE presidents stand on the broad shoulders of those who came before. This is something that continues into the future. You've got broad shoulders, mate. So look, on behalf, now there's drinks there, so give me 1 second. Look, on behalf of IChemE, of this fantastic place that we all love and that we contribute to, thank you very much for a really inspiring presidential speech. Good luck. Good luck. Exercise those shoulders.
I have to do my second and final presidential duty, which is to tell you the drinks are downstairs, okay? And that closes the proceedings for tonight. Thank you all for being here. Thank you.